Hi everyone, this is Harlak and welcome to another Java tutorial session. In this tutorial I will be discussing method overloading. We've actually been encountering method overloading when we talked about or we discussed constructors. So if you have a class with multiple constructors and each constructor takes different argument types, then that's an example of method overloading. Okay, so in this tutorial, I will actually be talking about regular methods and how they're overloaded. Okay, so let's just get started. So I'm gonna create first. Let's just say total price. Yeah. So in this total price, I'll take a quantity. That's an int type, and just say it costs $10. Okay, so we don't have this method. So let's generate it. Okay. By default, if I generate it, it'll generate as a static method. Right? So we'll keep it simple and keep it as static. So we'll return it as a double. Right? And here, call it Q for quantity and P for price. Okay. And here we'll actually do the Q times price, right? Okay, so that's what we have right now. All right, so here we go. If I run it, we just simply output. Well, it doesn't output anything because I haven't printed anything out. So let's print something out then. Right. So system write out print. Okay, so in here I'll just say that we're actually calling this, right? So the parameter type, so it'll be int and double. Okay, so I'm just printing out the actual parameter list here. Okay, so let's just do that. And I'm going to do something else here. I'm going to make it so that when I print it out here, it'll actually use the return value. And instead of typing system all the time, let's just do an import for system. Okay, so now out.print line. Okay, so I'm just going to print this the values here. Okay. All right. So now let's try running there. Okay. It'll give us 20. All right. Now, if I actually now to overload this method, I'm going to switch the price and the quantity. So instead of typing it all over again, actually I can do this and just switch it around. Right. Let's just say that this is 3. Right. Just to distinguish it. Let's see if it knows how to generate it. No, it doesn't know how to do it. Okay, so then I copy this and then just switch the two lists numbers. Right here, BQ, and get rid of this. All right. So I'm going to print this out so we know what's here. Right, so we have here the list in reverse, basically. So price here, quantity here, so double int, so you can see the method being overloaded here. All right. So print, and give us 30. Right, so it knows which one to actually call to invoke based on the type. Now, one thing to note with method overloading is that the return type doesn't really matter. All right. So we could just as easily say int, right? Well, the problem with that is that when we return int, right, because the result of multiplying an integer and a double is that you get a double. So if I return it as an int, what happens is that we're actually downcasting, right? And if we downcast, we're actually losing some information, all right? To actually force this downcasting and to say that we're going to lose, we're willing to lose information, we can cast it. All right, so we can cast this whole thing. All right, and when we return it, so why is it still complaining? Return double, cast to int. Well, I am casting to an int. All right. Okay, you know what? I know why it's complaining. I'm just gonna cast P. All right, because P price is the double. All right, so I'm casting it to an int. I'm saying I'm willing to lose it, the value. Okay. All right. So now if I run it, it's okay again, right? And you notice that it prints out 20 instead of 20.0. All right. So now that's an example of downcasting. All right. And again, with method overloading, these are ignored. Okay. So if I actually did something like this, all right. So let's just say that we do the Q thing again. All right. All right. Now you see that it's already defined, right? It says that it's already defined, all right, even though we have different return types, all right? So that shows that return type does not matter when it comes to method overloading, right? It just ignores it. So I'm going to change it back. Okay, so that's an example of downcasting here, all right? Now let's see what happens when we do this. All right. So when we do this, all right. So if we do this, something like this, and we remove it, right? It says here ambiguous method call. All right. So ambiguous method call because we have here 2. All right. So first it'll call this, right? But now the problem that we have here is when we actually do something like this. This is called upcasting now, or promotion. Okay, so we're promoting the type. What do I mean when I say promoting the type? All right, let's just keep it as is. All right. Okay, so 0. All right. So if I keep it as this, right? Now let me create another method, right? I'm going to create another method. I don't really need to print it actually. So let me just call it. Let's call it square. Right. Okay, so in square, let's just make it a double type. Right. And I'm just gonna. This is just basically we're gonna square something, square a number. All right. Okay, so again, I'll just keep it as void, and this is okay. I keep it all the same value, and let's just say that we're gonna square this value. All right. So be a double. You know what? I'll return this. Let's return this as a double. Okay. All right. So that's what we have right now. All right. So why is it complaining still? Oh, it's v times v. All right. So we're squaring this value. Now it says that it takes a double. Okay. If I do this, notice it's still correct, right? It's not giving me an error or anything. Okay, this is an example of promoting, all right? Because an int, okay, an integer takes less space than a double. It'll promote it, right? So now this is what's happening here is it's actually making a copy, right? Instead of the original one is still preserved. So this is passed by value, all right? So the number 3 here would just be copied into V, and it'll be 3.0, right? So it'll work with the double. The original value is not changed. Okay, so that is an example of promoting. Okay, and this is the reason why when we do something like this up here, right? We go back to this example, all right? Because it becomes ambiguous, all right? Because 2 looks right for the first overloaded method. Right, but 2 can also be promoted to the double over here, right? Okay, all right. So it becomes ambiguous. It doesn't know what to do. Okay, so the same case is when it comes to 10. All right, so 10 can be promoted to double here, and it also works with the quantity Q here. All right, and luckily the compiler catches this for us right before we go into runtime. Okay, so here we have to actually resolve that. Okay, all right, so here's an example I've actually discussed about method overloading, but at the same time we can talk about downcasting and promoting. Okay, and I actually have a list here, right, of the type and the actual promotions. Okay, so with the double, there's no valid promotions. Okay, float takes less space and gets promoted to a double, long to float. And here this was our case. So you're actually putting your argument, right? So like square, right? You pass in the number 3, which is an int. It gets promoted to a long, float, or a double. Okay. And with Boolean, I'm just going to jump right down. With Boolean, there's none because Booleans are not considered to be numbers in Java. Okay. So we have an example here of, let me just type this down. Let's say promotion, right? We're promoting, right? So the full name is actually argument promotion. Okay. And here we have, we're downcasting. Okay. So and then you got to be careful. You're losing some information here. All right. So we can actually see this better if I actually say, well, let's see, the price is 3, right? $10.30, right? And if I run it now, right, I still get the 20, right? Just because we casted P, right? 10, right? 10.3 becomes 10, and that's what happens. Okay. So I hope you enjoyed this video, and hope to see you in the next one. Take care. Bye.